Welcome back, everyone. I'm Steve,
And I'm Scott.
and together we're Backyard Musings, broadcasting live from Apple Valley, California.
The Science and Technology Channel.
So, all you peeps that are in Utah, listen up here. A new paper explains how the properties of fault rocks and geologic events that took place over a billion years ago could signal concerning seismic activity for Utah's population center. Utah's Wasatch Fault extends about 240 miles along the western edge of the Wasatch Mountains from southern Idaho to central Utah. It runs through Salt Lake City and other major population centers in the state, like Provo
Oh yeah,
and
Salt Lake,
Beaver.
County, Utah County. I mean, that's the basic area where everybody lives in Utah.
The
And
population
and there's
center, yeah.
there's more people in L.A. County in California than there is in the whole state of Utah. But most of the people live in that area that we're talking about.
This fault is classified as a seismically active normal fault, meaning it is a fracture in the Earth's crust that has shifted repeatedly over time. The research paper was published in Geology on April 25th, 2025, a peer-reviewed journal of the Geological Society of America. Would you like to know more? And when I say if your answer is yes, smash that subscribe button.
That would be great if you could do that. This is a quote. Normal faults are observed along different tectonic systems where the tectonic plates are moving apart, says Utah State University geophysicist Sridharan Sridharan. And I
That's
butchered
got to
that.
be made up, man.
I butchered that, I'm sure.
That's got to be made up.
Quote, going on with a quote, the Wasatch Fault forms the eastern edge of the basin and range geologic province, which is stretched and broken over millions of years, Sridharan said. Uh, and, uh, and he's an assistant professor in USU's Department of Geosciences.
The U, right?
Yep, USU, yeah. That's up Salt Lake, I think, right?
Yeah.
Yeah. Explains that normal faults typically resemble two slabs of rock. In these systems, the hanging wall slab moves downward relative to the footwall slab. Okay.
So that's together, and then one goes down.
Yeah,
Huh.
like a drop and
They're not like on top.
that's kind of like I think that's how the San Andreas fault is as well. I think it's this hanging wall footwall fault.
Quote, the dip angle of the sliding surface tends to be steep, often between 45 and 90 degrees. That is pretty steep.
Yeah.
He says, and he continues to quote, the Wasatch Fault plunges toward the west at a steep angle at the surface in the Salt Lake City area. But the 2020 earthquake, Magna earthquake, which occurred at about 9 kilometers depth west of Salt Lake City, caused injuries and resulted in nearly 50 million in property damages, Sridharan says. It was a wake-up call. We want to understand how and why it happened at such a shallow depth if the Wasatch Fault dips so steeply at the surface. I didn't know about this. This is probably why they're redoing the temple.
This is exactly right. Some of the steeple fell off of that temple.
Oh.
And so yeah, that's why they're updating.
It just like fell right down during the earthquake.
Fell on the ground. Yeah,
man,
it was crazy. So, I mean, again, this is where the majority of the people live in Utah, from north of Salt Lake City all the way down and about another 60 or so miles south of there. And
isn't there like a dozen temples in that area?
Oh yeah, probably. Yeah. So, but yeah, and that wasn't that long ago. But I'm surprised they haven't had any crazy activity since then. But anyway, with USU Geosciences Associate Professor Alexis Alt and doctoral student Jordan Jensen, Sridharan has published new findings about why earthquakes occur along the Wasatch Fault and why communities along the fault are more vulnerable to earthquake damage than previously thought. The research is supported by the U.S. Geological Survey's Earthquake Hazards Program. So,
using rock samples collected from the fault, Sridharan combined experiments and analysis in his rock deformation and earthquake mechanics lab with Alt's investigative expertise in earthquake geology and found rock textures at USU's microscopic core facility.
Now that would be a cool lab to go check out.
Yeah, shaking and see what happens. Yeah. Their research revealed significant clues about the Wasatch Fault's earthquake risk.
A steep angle could mean seismic activity may be dampened during an earthquake and spare inhabitants and buildings from much injury. and damage on the surface. Quote, although the Wasatch Fault dips sharply at Salt Lake City, it curves more gently at depth as it moves west and is probably oriented at a much smaller or much shallower angle at earthquake depth than expected, Sheeterand says. This means that an earthquake rupture could lead to stronger and more intense shaking at the surface, meaning a greater chance of injury and destruction.
Yeah. And like with the Salt Lake Temple, they pretty much raised up the whole foundation and then put stuff, and now they not soil now, they drilled, and they've got cables going up to hold it.
Yeah.
Right?
Yeah. In fact,
So
they
it's,
built a
the whole
machine
thing's
shop
going to
at
move.
the top of that temple.
Yeah.
Where they're building. That's fascinating.
Yeah.
Yeah.
The whole thing will move in an event, earthquake event.
And it's taken them what? They're going to be, when it's all over, I think it's going to be like 6 or 7 years by the time it's done. It's supposed to be done in 2027.
Huh.
They've been working on it for at least 3 years. So,
Yeah.
Yeah.
So further, the scientists discovered earthquake slip is possible along the shallowly dipping portion of the Wasatch Fault because the fault rocks themselves are much weaker, worn down, and slicker than the surrounding undamaged rock. It turns out this weak frictional behavior, which we characterize with deformation experiments and microscopy, is a product of deformation that happened more than 1.7 billion years ago, when what is now the Wasatch Fault was at even greater depths within the Earth. Alt says, continuing the quote, repeated past earthquakes since then have further modified the fault properties through time, priming the fault rocks to fail again in a future event.
Understanding how one rock is frictionally weaker than another, Sheeterand says, is like comparing ice to sand.
Ooh.
You can envision how slick rock can slide more easily and at lower angles than a rock with a rough surface, he says. This process is happening continuously, though, at a very slow pace under our feet.
Huh. Yeah, so for our folks up in Utah, I got family. Kirsty's got family.
I got family.
Yeah.
Lots of family. My wife's got lots of family.
Makes you think twice about that. I wonder if it extends to Logan, too, if those people get affected.
Well, the Wasatch range or front goes maybe
right
they call it a different range of mountains, but it's all the same mountain that goes up through there, starting way down in St. George, actually.
Yeah.
So
and up through Beaver, and then
yeah, those mountains are continual all the way up there. So, but yeah, hopefully
something to think about.
Yeah, you don't think about it in those areas. I mean, we're here in California, we're known for it, but when it happens someplace else, yeah, it's kind of a anomaly, people think, but no, they've had earthquakes activity up there. But just like we have earthquakes, like that thing I sent you this morning, it's what it's like 5 or 6 earthquakes. Yeah, a swarm of them, all under 4, but that's still
something's going on.
Yeah,
underneath.
Why?
You could get magma coming up at La Brea. Yeah,
we could have another Yellowstone Park right here in the high desert.
Well,
all
right, folks.
I wouldn't want that. Too many people would come here. So anyway,
thanks for joining us,
everyone. Thank you.
Smash that subscribe button.
Yeah, subscribe.